Good afternoon and welcome to the lecture on remote sensing and GIS in mineral exploration. So in this lecture mainly we will see how remote sensing is going to help in mineral exploration, and also we will see how GIS will help in integrating geological database for mineral exploration. And right, so as you know, remote sensing technology, that is airborne and as well as spaceborne, both can play a significant role in mineral exploration. Satellite imagery that is used to isolate potential ore-bearing provinces based on the remote sensing model of known mineral provinces. The whole idea is that exploring the unknown mineral from the known mineral deposits. So the signature of known mineral deposits, they have to be understood. Based on that, the same logic we have to apply to the unknown mineral deposits. So that is the basic principle of mineral exploration using remote sensing techniques. So remote sensing provides geological information, and this geological information, including the spectral and spatial signature, is used to locate new mineral deposits. And the most important advantage of remote sensing, that it reduces the cost of exploration because it allows us to focus on areas selected or shortlisted or the area prioritized for the further investigation using either geochemical or geophysical or very intensive ground-based exploration techniques like drilling and probing. So using remote sensing, we can cover larger area and we can find out the area which require detailed studies in shortest possible time. So that is where the value of remote sensing lies, and that's the reason actually since time immemorial, I would say the remote sensing techniques such as the aerial photographs, they are being used from the beginning of the last century, 1920s and onwards. In India also, the aerial photographs have been used. You'll be surprised to know the aerial photographs have been used in 1920s to locate iron and manganese mineral deposits in Odisha and Singhbhum of then it was Bihar, now it is the Jharkhand state. Now of course 1972 onwards we have the satellite remote sensing, and that plays a key role. Now we'll see there are some basic aspects of the stages of mineral exploration. That's very important to know, because the role of remote sensing, the kind of data, the type of data, what is to be used, it all depends on the level of exploration activity the geologists are engaged in. In different stages of the exploration activity, different types of geological data is required, and similarly different type of remote sensing data products are also required. Now, if the purpose is regional overview or reconnaissance survey, for example, many companies, they take up a country level or regional level study, and in that case also remote sensing can be used. In that case, we have to use the low resolution data sets. We can use remote sensing for the preliminary investigation. That includes mainly the surface geological mapping based on remotely sent images, and further the sites are selected for geophysical and geochemical exploration. Then comes the detailed surface and land surface exploration, and GIS-based image process techniques are further refined to greater detail to find out the areas further shortlisted for the further exploration. And the fourth stage, or you can say the final stage, involves detailed subsurface exploration that defines the mineral deposit at depth by airborne or surface geophysical survey and drilling. Nowadays also there are many remote sensing techniques which can be also operated from a short distance, and that can also produce good results. And we will see mainly the traditional guides of mineral exploration are the stratigraphic or the lithological guides, geomorphological guides, structural guides, rock alteration, and geobotanical guides. Now, so in all these guides help in mineral exploration, and remote sensing indirectly helps to establish the stratigraphy or the lithological distribution of different rocks, And similarly for geomorphology, structure, or rock alteration, and geobotanical anomalies can be determined. See, why the stratigraphic guides are very, very important? Because certain types of deposits are confined to rocks of certain age. So like coal, iron and manganese, they belong to particular age in a region, and therefore there is significant stratigraphic control, and this stratigraphic control can be linked to some kind of a lithological control, and this lithological control and stratigraphic control can be interpreted from the satellite image. Rock type analysis of the stratigraphic position can be remote sensing data, and attention can then be focused on some areas of greater interest where the potential, the concentration of the mineral is very, very high. In a way, I would like to emphasize that, see, the rock, the mineral, target mineral bearing rock can be very, very extensive, and it places where it is likely to be localized are very, very specific, and it has a geological reason for that. Now we must find out what is the geological reason for the concentration or the higher level of availability of a certain element what we are looking for. For example, iron. If you take the iron and you find the host rock is banded hematite, jasper or banded hematite, quartzite, overall it will have say 40 to 45% of Fe2O3. Now if you want to have the ore, that has to enrich up to more than 60 at least. So that means you have to look at the areas where the iron has been concentrated beyond this average in that area. So average could be found in the banded hematite jasper, which is a host rock, but much more than the host rock, we have to find out the locations where the probability of iron enrichment is there. And that is possible for two reasons. One, which is that the other elements or other minerals which are associated with the ore, that has to somehow leach out and reduce in proportion, so that the ore, what we call ore, that increases in proportion, and the percentage of a certain type of mineral is much higher. And so that's the overall strategy, that looking at a particular favorable rock or a particular horizon is not enough, but that's a fast thing to do. So this is what the stratigraphic guides or the lithological guides help us. The next comes the lithological guide, which is somewhere or other linked to that, linked to the stratigraphic guide. But some cases, the rock types maybe they are from the different, they may belong to different age or the geological age, but they still contain the similar type of the ore. So in this case, there are examples of banded iron formation, coal, and mostly they are regular and very, very extensive. In case there are syngenetic sedimentary deposits, and multispectral characteristics can help to identify locate lithological guides. And some mineral deposits, first one is some mineral deposits are confined to certain rock types. That's the reason that we can use remote sensing. And to tell you, there is a close relationship between the rock type and the type of soil derived from that. And that also, even though we may not be able to see always the bare rock, but the soil derived from the particular rock will have certain kind of subtle spectral characteristics, and that is what we have to look at it. And indirectly looking at the vegetation growth, looking at weathering, the erosion, and all those characteristics we have to identify. We have to map the boundary of a particular litho unit, and then have to have field visits to find out or reconfirm the occurrence of the particular lithology, which we consider as the host rock for the target mineral or the target ore. Geomorphology is very, very important. As you can imagine that, as you know, the secondary type of deposits produced by weathering and erosion, they have a direct bearing on the geomorphological setup of the region. Certain landforms which are associated with the ore types, for example, bauxite, for example, and it's a plateau type topography of the landform which is formed, and very, very characteristic table type landform. And and it can be recognized, and so, for example, the iron ore ridge, this also can be recognized very nicely, and this provides geomorphological clues along with the geomorphological attributes, so that the relief, drainage, the slope, so which are somewhere or other the geomorphological attributes of the terrain can be analyzed to potentially identify the areas where not only the favorable rock or the favorable structure is present, but also it has a possibility of getting enriched to ore is there. So, and also another area is the area of the placer deposits can be located based on the detailed geomorphological analysis. Now, the geomorphological analysis, in a way, it depends on several aspects. One is doing the geomorphological analysis for remote sensing, doing geomorphological analysis with the aid of the topographical maps, and also doing the geomorphological analysis in the field. So, all these field information, topographical information, and the satellite based in satellite derived information, they have to be correlated to find out some kind of a signature of the ore deposits, which can be extended from known to the unknown area. Now, it's very interesting why this geomorphology is so important, because that is something we see on the surface of the earth, and that is what is also seen by the satellites. And geomorphology is overall expression of the structure, underlying structure, and the lithology. So, for example, some mineral deposit may have a direct topographic expression, and topography may give clue to understand the structures responsible for the mineral accumulation, and understanding of the geomorphic history of an area may make it better appreciate. It helps to appreciate physical conditions under which minerals accumulated or enriched. So, principally, there are three reasons why this geomorphology is so important, and we will see some of the examples later. Now, coming to the structural guides, as you know, mineralization often occurs in structural beds, shear zones, fault fractures, and joints. And always the exploration experts look for the satellite evidence of structural features along the orogenic belts, extension of the fault or the intersection of the faults, extension of the shear zone, and like this, sometimes the contact of two lithological units and demarcated by a particular structural feature. The remote sensing data is used to focus in promising areas for further exploration. So that's the reason why the blend, as you see so far, there's a blend of the traditional knowledge and the modern tool to explore or improve the efficiency of locating or prioritizing the areas which you need to look into in greater detail using further ground-based or expensive ground-based or geophysical, geochemical exploration. And another one is the rock alteration guides. Alteration zones are often marked by the hydrothermal mineral occurrences, and they are the ones which can be easily found using the remote sensing media. And that remote sensing gives a very distinct spectral character for different alteration minerals. Each group of minerals has a different spectral characteristics, and two examples of common mineral groups will show you. And this is one example where the alteration zone minerals, something like kaolinite, multimolonite, salicite, muscovite, biotite, chlorite, and so on. There are several minerals which occur in different zones, and each of these zones is characterized by a certain set of minerals. Now, these set of minerals we may see on multispectral image. Looking at the spectral response of each point, we can find out what type of mineral is dominating, and the most suitable technique is the hyperspectral image analysis, which will take the data in discrete spectral bands and tell us what type of mineral is dominant. And looking at one or two minerals, we will say that, well, what zone is this? Now, once you identify the zone, then we can correlate that zone to some kind of a mineral deposit model. So at this point, I would like to say that the mineral deposit, each mineral deposit, it's unique, and you have to accept this fact. And some of the general observation can be made about a mineral deposit, but each deposit is unique, and that's the reason it's often very, very difficult to apply a general thumb rule to the mineral exploration. But however, once we know a similar kind of deposit is there, a kind of a deposit is there, some broad guidelines can be made, and based on the broad guideline, we can look for the mineral enriched zones nearby or the surrounding areas. And as you see here, the hydroxyl bearing minerals such as the clay and the silicate, which contain ALOH and MgOH, bearing minerals and hydroxide. They show a prominent adjacent feature at around short wave infrared region 2.1 to 2.4, which corresponds to band 7 in case of the thematic mapper, and high reflectance value for the 1.6, which is the mid infrared region. Now, the ratio of the TM5 and TM7, that yields actually high values for the alteration zones than the unaltered zones. So this, in a way, this ratio actually helps to find out which are the areas having the altered minerals, like the clay minerals. So from that altered product, we can look at the parent mineral, and from the parent mineral, we can look at the associationship, and from the associationship, we can say that what kind of deposit would be there, or whether there is a possibility of finding out the extension of a known deposit. Now you can see this, there are three iron ore, prominent iron ore minerals, and their spectral characteristic is shown here: hematite, goethite and jarosite, and band ratios like the TM1, TM2 or TM3 refers to thematic mapper 1, 2, 3. So all these ratios, they can be considered to find out whether there is hematite, goethite or jarosite, and this is what helps mostly in the oxide minerals, iron oxide exploration. And this is one example, again some kind of a two-axis plot, TM4 upon TM1, and in the y-axis, in the x-axis is a TM3 upon TM1, and it clearly differentiates the vegetation, goethite and the hematite. So this shows that the spectral bands, which are very, very broad bands, in case of the thematic mapper, but nevertheless they help to differentiate the goethite, the hematite and the vegetation in a specific case. Not always this kind of distinction is possible if the deposit is completely covered by the vegetation. But nevertheless, looking at the vegetation response, looking at the soil, structure, geomorphology and lithology. So looking at all those aspects in a work scenario also, we'll be able to find out scale potential areas. And that's the beauty of using remote sensing, because that is what enhances your traditional ability, traditional knowledge with a additional tool and information. That is what we have experienced with the last case study. I will be showing about our experience on that. And so that's the reason, even though it is extremely difficult and the things cannot be generalized, but still it can give you enough information to potentially identify areas where further exploration should be taken up. And this is one example from abroad. This is a color ratio composite of a part of a silver bell porphyry copper deposit, and the arcuate yellowish orange band that trends from left to right, that is the actually alteration zone, and that corresponds to iron oxide and clay, and this is very, very important for the copper mineralization in this area. Now, if we look at the TM3 upon TM1 and TM5 upon 7, like a ternary diagram, green, red and blue, TM4 upon TM3. So these three ratios are displayed. Together in a ternary diagram, and you can see the vegetation where it appears, and the clay and the iron oxide where does it appear. So iron oxide on one side and the clay on another side, and then the vegetation over here. So such kind of ternary diagram allows you to visualize the occurrence of clay, or it allows to distinguish or differentiate or discriminate the clay from the iron oxide and the vegetation. Now this is the aster image, and as you know, aster having large number of bands, which are very, very geologically very significant bands are there. And in case of the Escondida mine in Chile, the data has been analyzed, and you can see the aluminum hydroxide bearing mineral appear in different sets of blue, purple and MgOH bearing mineral appears in sets of green, yellow, and AlMgOH bearing minerals appear in sets of red. So such kind of discrimination is possible, and this is one of the area where vegetation is very, very low. So that's the reason that greater detail of element composition could also be interpreted. Now, this is a very nice example of the use of remote sensing for the uranium exploration. So you can see these a block diagram showing the alteration breaching zone in the overlying wind sandstone associated with the uranium mineralization and depth. False color composite shows the red and olive green color in the bleached part of the overlying formation and shades of gray and beige on bleached winged formation, and uranium body is linked to the alteration zone as you see in the 3D picture. This is what the uranium is buried, and this is the response alteration zone is seen closer to it. So that's power of remote sensing, that even though the uranium percentage normally which is very low and underneath, but still the alteration zone can be seen from satellite image and some light can be thrown on the occurrence of uranium. And this is a fusion of 5-meter resolution IRS-1C and 25-meter Landsat EM satellite image, and the image shows iron oxide and clay alteration zone, and so such kind of zones also help to identify and map minerals. This is very interesting, iron oxide and the clay dispersion in stream. So the lighter the clay mineral disperses further downstream, and heavier the heavier matter actually remains there. So this is the one picture showing the dispersion of the mineral dispersion with respect to the gravity. And geobotany, as you know, the vegetation is the first thing which can be seen from the satellite image in case of the tropic and subtropical region, and that's the reason we have to understand the relationship between the plants and the rocks, and rocks with the ore. And the spatial distribution of plant and plant community is very important, and vegetation characteristics also very important. We'll see one of the example how the geobotany is helpful for the mineral exploration. Vegetation often influenced by the mineralization, lithology, rock fracturing. Sites with high concentration of the old mine waste or mine tailings for lead, zinc, copper, nickel and other metals may develop unique floras because condition is toxic for most species. And these unique floras, to some extent, they can be, their spectral response is different, and this attempt can be made to map those. Structural occurring saline or alkaline deposits and serpentine outcrops also develop unique floras. Leaf concentration of trace metal may indicate the composition of underlying soil and thus may be useful for the mineral exploration. Now this is one diagram. You can see the growth, natural growth of the trees, how well it growing over here, and wherever the mineral body is there, how the growth has been reduced. So vegetation anomaly, this reduction in the growth of the vegetation leads to some kind of anomaly. Now this anomaly, if we are able to see, now that can be used to locate the new mineral deposits, because this is the metallic sulfide deposit, and because of this we have a vegetation anomaly, and this anomaly if we are able to detect, we should be able to detect about the metallic sulfide. Now coming to the hydrocarbon exploration or the oil traps. So you can see there are various types of traps, stratigraphy, structural traps, and each trap is the host rock is exposed to the surface, and remote sensing can be used to map those. And we'll see another example where the geomorphology plays a significant role, how the anomaly in the geomorphological anomaly is linked to the oil deposit or the oil reservoir. So this is mainly for the hydrocarbon, the oil exploration, and it's in part of the Assam, and you can see the areas dominated by the anticline, and this is where the axis of the anticline goes, and this has helped to interpret and map or target the areas having the oil. You can see here that all along the lineament, the oil, how the oil is located. This is part of the Colorado. Now oil slick in the sea. Suppose there is a deep fracture, and the fracture leads to the oil reservoir, or and finally oil seeps out. So that will form some kind of a streak. And this streak, because of the different surface tension and also spectral property, it will appear smoother, and it is possible to detect using optical data and the microwave data. So that is what has been attempted here. And we'll move now to one of the most important iron ore deposits of of India. This is the eastern belt or the iron ore group or iron ore super group, and you can see here this is in a synclinal form this deposit is located, and this side is the western ridge, and this is the eastern ridge. Western ridge is overturned, and you have all these black ones are the banded hematite jasper or banded hematite quartzite, and here also iron deposits are there, and here also iron deposits are there. Now in this case, what we have used the satellite data like the IRS list to those days. It's a quite a old study. So, and nevertheless, it's very, very important study because it helped to understand one of the oldest iron ore deposit of India, where the remote sensing was perhaps for the first time was used 1920s for the manganese exploration. So ERS1 SAR data was used along with the optical data, and extensive digital image processing were carried out. So you can see here ERS1 SAR data has been different dates, 3 different dates have data has been procured for 3 different dates. A reason being that we wanted to find out is there any seasonal impact or effect on the scene interpretation. That's the reason why 3 dates were taken. Then using these 3 together, the overall topographical effect was determined using the KL transformation, which reduces the speckle because 3 dates data it combines, and as you know the speckle noise is very random noise, and when you combine 3 different date data, obviously the speckle noise is going to reduce and image interpretation capability going to improve. And when you use the 3 date data and take the KL transformation image 1. So KL stands here for the Caronan and Lowe transformation, which is like a principal component analysis. It's like PC1, but principal component, as you know, is calculated from the variance covariance is calculated from the correlation matrix, whereas the KL transformation is done using the variance covariance matrix. So that allows actually little more information on the lower order PCs. Which here we call them as the KL, Caronan and Lowe transformation. And when we combine the hue, saturation and intensity transformation of TM234 and intensity we bring from the SAR KL, that highlights actually, it makes a beautiful combination of synthetic aperture radar and the optical data. So both are fused together. Synthetic aperture radar gives more detail about the structure, geomorphology, topography, and the spectral data gives information about the spectral properties, and when they are combined together, it becomes the data becomes much richer in the content and geological features like different type of lithoids, the structures, geomorphical details, mining status. So all those details can be derived. And differentiate lava TM754 also was produced. That differentiate lava from the shell and highlights mining areas in green. It's good for lithological interpretation. And TM65 and SAR synthetic aperture radar Caronan Lowe 1 surface cover mining, and ratio image 3/4, 5/2, 3/2 highlights Fe and Mn mines and the lateritic cover. This is the iron ore group. This is the iron ore group, and this is the Singhum granite, and this side is the Daitari, and this is the range. And here, this is the one limb. Iron ore supergroup syncline or iron ore IOG syncline is a double plunging. It's a plunging syncline and plunging towards north east, and the direction, the western limb is actually continuous one. Of course, there is 1 or 2 places of fault, and eastern limb is highly continuous and deformed. And this is the one part of the limb showing the iron ore ridges. And this is the ERS1 temporal FCC, how nicely all the geological structures coming out very nicely. And you can see these different classes of object closer to the Himalayan front, closer to the western limb. And so this is a W-shaped plunging syncline. You can see this is what I am drawing it. This is the western side. And then we come to the eastern side, and finally this is the eastern limb, which is completely disturbed. The eastern limb is disturbed because of the synchrone granite, which occurs towards the further east, and this limb is actually overturned, westerly dipping, and here obviously this is a syncline, so here it is mostly westerly dipping, but this is what westerly dipping and at a steep angle. So that makes it a some kind of a overturned limb of the syncline. And when we combine the optical data with, this is a combination of optical data and the synthetic aperture radar using the hue saturation and intensity methodology, in which case the color component comes from the optical and the structural or the topographical component comes from the microwave data. So all are combined together. You can see the red patches are the one where you have the mining status, mining is going on, and these areas. And so this is a great product. It combines the advantage of the micro remote sensing along with the advantage of optical remote sensing. Mostly the spectral information and the structural information comes from the radar. Both are combined together to produce an image where each feature actually has each feature highlights the other, and both the positive aspect of optical microwave remote sensing data has been utilized. And based on this data interpretation, we have found the potential areas. So all these existing mining areas that appear as a potential and additional areas also have been identified. Now this is how it does look like on the field. So I hope you are able to see this, or the lecture note can be shared with you. So this is a 300-meter ridge from the 200 to 300 meter ridge is very continuous. This is the Joda East mine, and you can see gently sloping areas mostly underlain by the manganese, and mostly the iron ore occurs on the top of this mountain, top of this hill. So in this form, so first few meters we have the lateritic soil, and then the hard massive ore, then the soft or the less massive ore, and finally the blue dust. Now coming to the GIS, we have seen that remote sensing can help in mineral exploration. We saw various examples, starting from the foreign examples to the Indian example. Integration of optical and microwave data also we have seen. Now when we have several data layers, geological data layers, how to integrate them together to point out or to find out the further prospect areas. So this is how it is carried out using GIS. Fault, geology, geochemistry, geophysics is combined together to generate the prospective map. And this is one example. There are various techniques, very advanced techniques are there, how to combine the geological information, independent geological information. Some may come from the satellite remote sensing, some may come from the ground-based observation. But the whole idea is that different types of data, they need to be integrated, they need to be combined to find out the potential areas for the mineral deposit. There are two approaches in this case, how the data will be combined using GIS. It's a simple overlay technique. Overlay technique doesn't, it does in very limited answers, or it is it can be useful to a limited extent only. And that's the reason why we use several advanced techniques to integrate the layers. Some layers can be derived from the remote sensing, some have to be derived or obtained based on the field data. In this case, there are two sets. One is the data driven, another knowledge driven. As the name suggests, the data driven approach, mostly the model parameters are calculated from the actual data. Logistic regression, weights of evidence modeling, neural network modeling are three popular modeling techniques that can be used for the mineral exploration. And second one is the knowledge-driven approach, and mostly it is driven by the the human knowledge about the particular deposit. And we have like Bayesian statistics, fuzzy logic, Dempster belief theory. They are essentially derived from other branches of science, like Dempster belief theory comes from the medicine, and but they can be used to locate the minerals. I'll show you one example how the fuzzy logic is used. This is how the fuzzy integration has been done using fuzzy gamma operator or the fuzzy OR operator. And so using the fuzzy logic, the parameter layers like the geology, then the favorable geochemistry, then the anticline and the biogeochemistry, gold deposits and all. So all these things have been combined together to find out the probable areas, and all the layers have been integrated using fuzzy OR and fuzzy and finally they are also combined together. We'll see the result. So this is how it looks. The red patches they are having high membership value, and essentially those are the favorable areas for the mineral exploration based on the inputs, and all these inputs have been combined together based on the some kind of a logical rule, and the rule is defined mainly by the fuzzy logic, and which is essentially depends on the membership function of different layers. So it shows that the areas that according to the fuzzy membership value, fuzzy set comprises those locations that satisfy the proposition that favorable for the gold exploration. So this was exercise aimed at doing the gold exploration, and the one of the best paper about this area appeared in 1991-92 period by Bonham, Carter and Achterberg. So using the weights of evidence modeling, and subsequently the same group along with the other Chinese worker, they have used the fuzzy membership, and these techniques have been extensively used in different parts of the world and for the mineral exploration. So with this I come to an end. I would like to say that mineral exploration in short requires, there are two aspects. One is the deriving information from the remote sensing data, which principally can be of airborne or it can be spaceborne. If it is spaceborne or airborne, also it can be either optical or microwave and sometimes thermal data. So all the data sets can be combined together to locate areas which are good prospect for the target minerals. That is one aspect of it. Second thing is that some of the some of the parameters derived from the remote sensing and traditional geological data layers, they can be combined using knowledge-driven approach or using data-driven approach. There are several methods, several techniques with strength and the weakness, and each technique can produce a mineral potential map. So this mineral potential map can be cross-checked against the actual mineral deposits, and to check how far we are able to successfully predict areas and unknown areas where these promising areas can be discovered by this technique should be taken up for the further exploration. So this is a strategy, two types of strategy. One mainly using the remote sensing, second one is using the remote sensing and GIS with ancillary geological information. So I come to the end of my presentation, brief presentation, and further if you want to know more details, and I would request that all of you look for some opportunity to come to IRS for long-term courses, because mineral exploration is a ultimate end result of geological training and geological interpretation, geological investigation. So after you do everything, then you can apply it for the mineral exploration. So the best is the long-term training. We have the PG diploma and MTech programs, and people can join these programs and learn all the details of image interpretation, image analysis, data integration to apply for the mineral exploration. Thank you very much for your kind attention. Okay, come to the thank you very much. A lot of questions, so that shows that all of you are very active. So we will take it up one by one. How can we locate buried channels, pipelines using geomorphological guides? So the buried channel itself is a geomorphological feature. So you can always have the spectral and spatial signature of buried channel, and based on that you can actually once you identify the buried channels, then you have to look for, in fact, buried channel you have to see always what mineral deposit you are looking for. Can it be located using the or identifying the buried channel? So that relationship has to be known first. So I would like to emphasize that the mineral deposit model you are looking at or work at, that has to be understood first. It's not simple identifying the buried channel and telling that yes, I will have the mineral. But the point is that you have to think in your mind what model, what is a mineral deposit model you are looking for. So once that is known, and it's a difficult thing what I'm asking you, that sometimes some kind of already studies have been done, and wherever you are going, you'll find some kind of geological studies already have been done. So based on that, approximately you know that what is the type of mineral deposit you are looking at and mineral deposit model. So accordingly, if it buried channel, it is very significant thing for that. For example, diamond or gold exploration, if you think that yes, buried channels are important, and if you think so, then you can use the geomorphology. And to interpret these features, actually what you require is the moderate resolution to high resolution, optical and microwave data, both are required to map the buried channels or the pipelines. So both these data sets, and I would prefer that some kind of a temporal data set required, because it is very, very sensitive to the moisture content. Moisture content is largely dependent on the season, and that's the reason actually you should have at least seasonal coverage, 2 time period in the case of India. So one dry period and one can be just after the rains in month of October and April, May. So 2 data sets, optical and moderate resolution to high resolution. I mean to say the least 3 and least 4 type of data. And one more, you should have the very high resolution pan-chromatic data, for example, Cartosat 1 or 2, Cartosat 1 preferably. So using this combination along with the microwave data. So microwave data, depending on what type of data you can look for, always for paleo channel, the L band, because of higher penetration, we always go for the L band if it is possible to have for this area. So combine the information using the L band, SAR, optical and multispectral 2 time period data. So that should be able to give you details about the buried channel or the valley fields linked to the mineral deposit. And okay, so this we have done. And then what is suitable methodology to prospect for gold deposits in basement? So when you say the basement, so that means you are looking at mostly the structural and the lithological features. So basically the mineral deposit model you have to understand what is the structural control of the mineral deposit. So structural control, once you understand, then you have to explore or look for the similar control where the known deposits are there. So mainly it is a structural interpretation and structural anomaly, which involves lineament analysis, regional lineament analysis, and some kind of a tectonic analysis. So you have to consider those aspects. Now, okay, so this is we have explained. And then question from the Gurukul Kangri University: what is the resolution used for the lithological analysis? I would prefer that lithological analysis we should use something like least 3 sensor, and some cases least 4, but preferably least 3 sensor is ideal sensor. And if you are doing a regional scale mapping, then the A widths of 50 around 60 meter resolution is also good. So such things are required. Then we'll move to the next question by Chandan Kumar. What kind of hydrothermal alteration mineral zone could be a significant indicator of lead, zinc, copper deposits? When you say about the hydrothermal alteration, Your target should be very simple minerals like the iron oxides, gossans, and the clay-bearing minerals. So you should look at the gossan and associated minerals, iron, particularly the hematite, goethite, and the clay minerals. So these are the minerals you have to look for, and then you have to see how these minerals are related to your lead and zinc copper deposit. So based on that, a strategy should be made, and not only the alteration mineral, you have to find the alteration mineral, and of course, which is reasonably easy using the hyperspectral sensing data. But this has to be combined with the geological model of the deposit along with the structural data. So that makes the story complete. Yeah. And then we move to the next question. Water Resource Department, Government of Maharashtra, Nasik. Mineral totally covered by vegetation. How do you really identify? This is a tricky question, and basically the vegetation, if it is covered, vegetation is covering. So it's not necessarily that you will not get any information. You will still be able to get some information, because there's a good relationship between the soil and the rock type and the vegetation. Plus the canopy, actually for a similar type of vegetation, the canopy almost takes the shape of the topography if the vegetation type is same and similar type of growth is there. So more or less, even though we look at the canopy from the satellite data, still we are able to, many cases, able to interpret the broadly the geomorphology and the geological structures. So in the worst scenario, I would say that you will be able to get some information about the geomorphology and the structures. And perhaps if the good thing is that whenever you have a mineral particularly exposed to the surface, normally the vegetation growth is not there. For example, the lateritic iron deposits. So on top of that, actually trees don't grow. Similarly, if the bauxite deposit is there, trees don't grow so well. So if you have the mineral, actually you may not have the good amount of vegetation that indirectly will help you to look for the target. But many cases there could be the vegetation, and the best way is the one has to go by indirect way and possibly try for some kind of a geobotanical relationship of the mineral deposit. And if that is there, then it becomes easier to use the spectral characteristics of trees, vegetation to link it to the soil characteristics and the minerals below. Water resource, okay, this is over, and we'll move to the next one. What are the effective methods of geothermal exploration using remote sensing techniques? Of course, the moment you say geothermal, so you have to look at the thermal data, and that is obvious. You have to look at the thermal data, and if you want to understand the complete three-dimension mineral deposit, in 3D, the distribution of the structures or minerals, then along with the thermal data, you have to look at some kind of a gravity data, and and some cases also the multispectral data will help you. And we'll move to the next, Central University of Jharkhand. How does the fuzzy membership value calculated? Fuzzy membership values that can be calculated statistically. There are various methods. Or you can derive it, you can give it yourself, the fuzzy membership value based on your knowledge related to the mineral deposit and the parameter which is we are considering. For example, a lithology. One lithology is very, very good for a particular mineral deposit. So I'll assign a fuzzy membership value 0.8 or 0.9. Similarly, statistically, I can find out what is the relationship of the rock type and mineral, and based on the statistical relationship, I can give a correlation value, and that correlation I will rescale between 0 to 1 and tell that the membership value. Membership value is very flexible, because membership values they vary from 0 to 1, and unlike the probability, membership values don't add up to 1. So you have the full freedom of selecting the membership value. You can derive it statistically, or you can give it from your mind, your experience. So both way it can be done. And what is important is the fuzzy integration. So then you can select a method of fuzzy integration. Yeah. And okay. Anu Anthony, what are the most effective method for geothermal exploration? I think this we have done already. Yeah. And how topography gives a clue about the mineral and its zones? This is very good question, because this is topography is basically what is the geomorphology, landforms, and landforms are the actual expression of the lithology, structure, some kind of weathering, erosion, whatever is happening. So in a way, actually, the topography is a interplay of all the factors. So looking at all these factors, you have to link it to the mineral deposit or the mineral and its zone. So mineral and its zone, we normally try to define in terms of the geomorphology, the structure, the lithology, and some kind of alteration zone. So all these 3-4 parameters what we look at for a deposit, we have to link it to the topography. Yes, because topography gives most of the details. That's the reason we try to link it to the topography. For example, a hill, I know appears like a ridge, and not like a conical ridge. It's a flat top ridge. So such kind of things, such kind of areas can be demarcated, and type of the ridge, type of the hill, conical top or the flat top hill, all can be differentiated and linked to the mineral deposit. And we'll move to the next question. Is it possible to find a trace element data analysis using remote sensing GIS? I am not able to get this question correct. And if I guess it is about how can you do the trace element data analysis. So what do you mean by trace element? Which are the trace elements you're looking for? If you further clarify, because all these minerals we are looking at, for example, the gold, or they are the ppb level, so ppm level, and still we find the reasonable amount of the structural expression or lithological expression, alteration zone. So it's all about mineral exploration study is an indirect way of looking at the minerals. You look at the minerals based on their alteration zone. Alteration zone minerals do not tell you exactly directly what minerals are behind, but only it gives the path that yes, if you have this parent rock or parent mineral, this will be altered, and once it is altered, remote sensing is able to catch that. So from that point onwards, you have to link it to the mineral deposit model. So you look at the classical textbook of mineral deposit model, how the deposit occurs, and what are the primary minerals, and and which are the secondary minerals because of alteration. And once these are found, we have to trace back to the ore. Yeah. So we move to this. Next one is how hyperspectral remote sensing data will support the mineral studies. In fact, hyperspectral, as you know, there is large number of spectral bands. And these spectral bands help to get the spectral absorption or the reflectance peak of certain diagnostic minerals. So it helps to identify the mineral and in a much better way than the multispectral. So that's the reason it can be used extensively for the mineral deposit studies. How the dielectric constant can be useful for identifying the minerals in SAR images. SAR images, essentially, apart from the dielectric constant, SAR images essentially gives you the topography, what I have shown in the example, and this topography indirectly hints about two things. One is the subtle structural variations and the geomorphology. So you have the better structural details, and you get also the geomorphical details. So these two information can be combined together, along with opportunistically as and when possible to find out any dielectric constant variation in the different lithology. So then lithology or structural, weak zones, then it can be used. And what are the methods for the suitability analysis other than overall analysis? There are large number of methods, as I showed that regression method, for example, weights of evidence method, fuzzy logic method, Dempster-Shaffer belief theory, and simple probabilistic method. There are several methods can be used for this purpose. Mineral exploration and onshore drilling. If you look at the onshore drilling, the role of remote sensing is only up to the oil seeps or the oil streaks, and once we link it to the the reservoir, offshore reservoir, then the exploration part is over. So what then comes the operational part? If you mean to say that how the on the operational part, of course, remote sensing can be used. but mainly what we use the remote sensing for the onshore, mainly the oil deposit, and try to find out how the oil seepage or the oil streaks, how that are linked to the subsurface fractures. So that is the most important aspect. And then once the operation or the production starts, and then you have to do, of course, the routine exercises about the monitoring of the platform and the pipeline, so remote sensing can be used. What is fuzzy membership? Fuzzy membership, I think I explained a little before, that this is the closeness of a target with a, with one of the parameters. Closeness or associationship, or you can say resemblance, like that. It is something similar to probability, but the probability always adds up to 1. If you have 2-3 objects and 2-3 possible, the elements, and they belong to one class, for example, their probability of belonging to that class adds up to 1. But in this case of probability, in the case of fuzzy membership value, it is not the case. So in a way, if I say that I have a temperature reading, say 35 degree, and fuzzy group is, for example, one group is a hot group. So that means 35 degree centigrade will be very hot. So I would consider them that, okay, the fuzzy membership value should be around 0.8, for example. If the temperature is, say, around 22 degree, I would say that it's not very hot, so the fuzzy membership value with the hot group of that temperature would be, say, perhaps around 0.5 or 0.6. So fuzzy membership value is basically refers to associationship or the closeness or the resemblance of the target with the parameter. How is remote sensing applicable in oil exploration in desert? So desert oil exploration, as I said before, you can use it for the paleochannel detection and you can use it for the structural features and some of these topographical features. Those can be determined, and that way it can be helpful. Then which type of spectral bands are suitable for the mineral exploration using Landsat TM? Landsat TM, in fact, you should use all the bands, but most importantly, band 7 and band 5 are the ones. Band 3 and band 1 also good for the iron. So band 1, band 3, band 5 and band 7, at least these 4 bands are very good for the mineral exploration. Which marker mineral would be taken as mineral deposit over leaves? Mineral deposition over leaves. I cannot follow this question. I think there is something you have to be a little more clear about this question. If you mean to say plant leaves, then it's a geobotanical aspect. You have to look at it. So you have to see what are the minerals which can be, can be explored using geobotany as a guide. So accordingly, you have to follow the geobotanical principles. And okay. Now, does mineral Ashutosh Kumar Mishra, he asks, does mineral exploration help us to identify future coal mines or other mining projects? Of course, that is the whole idea. That mineral exploration should lead to the further deposits. So that is obviously the reason why the mineral exploration is done actually using remote sensing. So uranium deposit, if you want to study IITM Kerala, you have to look at the apart from the remote sensing data sets. You have to look at the geophysical data sets on the uranium count, thorium, potassium count, aeromagnetic data, geophysical data sets like aeromagnetic and the radiometric data required. So to integrate along with to integrate remote sensing with those data sets for the further exploration. Can remote sensing Central University of Karnataka, can remote sensing be used in mineral exploration in the marine environment? Marine environment, if you say that, as I said, the oil streaks or the oil seeps can be used to locate new oil deposits. On the coastal area also, marine deposits are there. Those can be used to look at the radioactive minerals. And some of the coastal areas also have limestone deposits. So those can be located. Now this is a question you have asked about the uranium deposits available in India. And yes, there are uranium deposits, of course, in India, and so still there are many places which is economically it may not be economical to mine at the moment, but there are deposits. See to what extent or to what depths the ore mineral. I have been telling again and again that remote sensing doesn't see the mineral. So there is no question of how, to what extent, up to what depth you can see using remote sensing. It is all about looking at the geology of the area, and to interpret the geology, you require some kind of mineral model, and geological information is derived from the remote sensing. And GIS only helps to integrate the data like geophysical, geochemical, and geological data can be integrated. So the question is that kindly remove from your mind, you do not see the mineral as it is. The way you are thinking that up to what depth I can see the mineral. No, you don't see the mineral up to certain any depth actually. So what you see is the basically geological information. Geological information they have to combine together along with the other information which is derived partly from remote sensing, partly from the ancillary information, and combine together to tell you which areas are prospective areas for the mineral deposit. So this we have answered already. Optical data, I think I have already said that can be used to map the mineral deposit itself, and it can be also used to map the lithological details, structural details, alteration zones, geomorphology. So all can help in mineral exploration. What type of mineral deposit in the wetland or the paleo wetland bed? No, there is no mineral relationship with the wetland. So paleo wetland and wetland, they have no relationship with the mineral. Mineral deposits, the mode of occurrence of minerals and the type of deposits, you can look for any standard textbook like Beckman or any standard textbook you can see, but there is no relationship, such relationship between the mineral and the paleo wetland. See, it is not only the spectral signature of two minerals match. What you have to see, the two different minerals what you are looking at, their spectral characteristics. Another one is their, what structural setup, what lithological setup it is occurring. So all you have to use the other parameters to distinguish one from the another. And yeah, this already we have answered. Then comes, see GPR, good question. GPR can be useful for mineral exploration in a way it can, subsurface characterization is something GPR aims to do. What is the material below the earth? So if that is going to, help in a way or other, particularly the layers or the horizon which is linked to the mineral deposit, certainly it can be used. Then what is the procedure for petroleum exploration using remote sensing and GIS? Is it necessary to integrate the thermal, optical and microwave data? Yes, it is important to integrate all the data sets for the petroleum exploration. What is lineament and fuzzy membership? Lineament is basically the geological structures and the mainly the geological structure. For example, fold axis, fault, fractures, which are mainly linear features having some kind of a 3D extension, and the fuzzy membership is basically finding out the relationship of the parameter, some kind of geological parameter with the mineral deposit. So the closeness of this mineral deposit and the parameter is defined by the fuzzy membership. If they are very, very close, membership value is very high, otherwise low. See, all the platinum group or anything, you have to find out whether it is possible to have any geological or geomorphological or lithological structural expression. So the deposit have to have some kind of a expression in the form of say lithology, structure or alteration mineral. Then only remote sensing can be used. There is no limitation to platinum group or any group. I mean, it all have to the mineral entire question should have some expression in the form of lithology or structure or alteration zone. So then it can be used. It can be in PPP or anything. I think this we have discussed already. You have to mainly use the remote sensing for the remote sensing and GIS to remote sensing to identify the previous waste deposits in landfill and decomposition, and so you require mainly, I think the best thing is that look at the hyperspectral data and look at the vegetation anomaly to find out the waste deposits. So based on that, you can use integration technique. See, you can know about the waste deposits using such spectral properties. I think this we have already discussed, how to identify deposits using vegetation cover, mainly through indirect method. I think the study material will be given to you. The PPT is what we discussed, it will be all sent to you. You can download it. Placer board is basically geomorphological expression would be there, and you have to do a very high resolution geomorphological mapping along with the structural mapping, and also you have to understand about the possible areas where the placer gold would have been deposited. So some kind of fluid dynamics also one should have knowledge to apply the geomorphology for the gold, the placer gold exploration. Now, it's always good to have field verification, so there is no question of without field verification. And Landsat imagery, which imagery you are meaning, there are different type of Landsat imagery, and you have to use the highest resolution available in the Landsat series. Landsat TM or ETM at the best, you should take those data sets. The weightages to the GIS layers can be given based on your experience, or if you cannot use your experience, then you have to use some statistical technique, and that is where or you can use both. You can use knowledge driven or statistical technique to integrate the layers. I think this already you have discussed. Fine. Green ones we have discussed, right? Yeah, one more question, that how can we identify the dolomite and limestone deposits? Dolomite and limestone, they have very good characteristic response at short or infrared region. In fact, if you have a hyperspectral sensor, you can differentiate this dolomite and limestone, and you need hyperspectral data for this. What extent this GIS is useful for the hydrogeological formation, and this is okay. At this moment, we are not discussing about the hydrogeology, so you cannot find out hardness of water using remote sensing. Okay, if there are no questions, okay, we say thank you for a keen interest, lot of questions, and study material will be sent to you. And those who are interested to pursue a career may kindly contact or look at our website for our MTech and PhD diploma course. You have to go to Geosciences and Geohazards in our website and look at the projects we have, and then you can apply for some of the courses. Thank you.